In this lesson, we are going to look at equivalent exponential functions. This means we're going to look at two exponential functions that have different bases, but in fact, they are actually the same. So let's just jump right into the first question. We are told that the function f of x has base 27 and the exponent is x plus 6. The question over here says what we want to do with f of x function, we want to change it so the base is 3. So what would the new exponent be? So we're going to use the exponent rules and figure that out. So we have 27, which is our base. We are going to change that to 3 cubed. I chose 3 because the question said 3. I want to change it to base 3. And I know that 3 cubed is equivalent to 27. And then to keep this the same, I have to make this to the exponent of x plus 6. So the first step I've done is change 27 to 3 cubed, and I still have x plus 6. And then I just want to expand using my exponent rules and simplify these two exponents. So to do that, I'm going to change this to 3, and then the exponent's going to be 3 multiplied with the x plus 6. So it's important to know that you're multiplying the 3 with the x and the 6, so that's why I wrote x plus 6 in brackets. And then I'm just going to apply that. So base 3 to the exponent 3x plus 18. So I have changed the f of x function into a new looking function, but in fact they're actually equivalent or the same. So just to complete the g of x function, for these to be equivalent, the exponent on this base of 3 has to be 3x plus 18. That line just says write your answer here. So before we do another example, I just want to talk about how these are equivalent. That means if you were to graph y equals 27x plus 6 and y equals 3 to the 3x plus 18, the graphs are actually the same. So in the first one, with base of 27, this graph, this exponential function, increases quite quickly because that base of 27 is quite large. So it increases quite quickly, and it shifted 6 units to the left. So you can see it's over here 6 units. And then in the second function, we have base 3. So I drew the base graph of y equals 3 to the x. So it would be over here. It doesn't raise as quickly because the base 3 is smaller than base 27. But then there's a horizontal compression of 1/3, which actually makes this rise quicker. So it increases faster. And then we're shifting 18 units to the left. So then we would get over here. So even though the equations have different bases and the transformations look different, those transformations are what makes these two functions equivalent. And then next, let's look at the table of values for each. So the first table, we will plot points for the f of x function for when x is -2 to 2. And the second table of values, we will plot the points between x is -2 and 2 for the g of x function. So I've just shown my work before I find the y value, and I've just substituted the x value for each line into the x. So 27 to the -2 plus 6 is 27 to the +4. And then when x is -1, I have 27 to the -1 plus 6, which is 27 to the 5, and then so on. And then for the g of x function, I just substituted in those same x values into the x. And I've highlighted that in red. And now I'm just going to use my calculator. These are going to be big numbers. 27 to the 8 is going to be quite a large number. So now I've just used my calculator to evaluate each y value. So 27 to the 4 is 531,441. And then when you get when x is 2, 27 to the 8 is actually such a large number that I had to use scientific notation. And that's what happens with exponentials because they increase so quickly, exponentially, you can work with very large numbers. So this is 2.82 times 10 to the 11. And then what you should notice is the y values for the g of x function, they are the same because those two functions are equivalent. So for the same x values, the output or the y value is also the same. So let's look at a couple harder examples and using the exponent rules to show that two functions are equivalent. So this question 2, the f of x function is 8 times 2 to the x minus 1, and we want base of 2. So what I'm going to do is I'm going to change the 8 to base 2 This base 2 with the exponent is already has a base of 2, so I just need to worry about the 8. So I'm going to write the 8 in red, and when I change that, I'm going to write 8 as 2 because I want base 2, and it's 2 cubed because 2 times 2 times 2 is 8. And then I'm going to keep writing the 2x minus 1. If this, for some reason, was base 4 or base 16, I would then also have to change this one as well, but it's base 2, which is what my answer wants me to have it in, so I can just leave that. And then using my exponent rules, I want to write this as one base. When you are multiplying two of the same base, you add the exponents. So I'm going to have base 2, and the exponent is going to be 3 plus x minus 1. And then I can just simplify that. That's x plus 2. Just collecting like terms, I have x, 3 minus 1 is 2. So now I'm just going to write that for my answer. X plus 2 is the same. And you can always graph this on Desmos to check if your original function and your answer look the same on Desmos. And if they do, then they're equivalent. In this last example, we are going to find two equivalent exponential functions for this f of x function. That is 1 over 16 times base 4 to the exponent 2x minus 1. I want to change it to a g of x function with base 4, as well as an h of x function to base 2. So first, let's change everything to base 4. So I have this 1 over 16 that I'm going to change first. So 1 over 16 is just 1 over 4 squared. The second, base 4, 2x minus 1, is already base 4, so I do not need to change that. I'm just going to keep that as base 4, 2x minus 1. Now, 1 over 4 squared, I don't want to leave it like that. I want the base to be 4, not 1 over 4. So what I'm going to do is use my exponent rules and change this to a negative exponent. So it's 4 to the exponent negative 2. Because what I'm doing, and I'm going to do this in dotted because you don't want to write that, but 1 over 4 becomes 4 over 1. You can flip the base and then change the sign on the exponent. And then again, I still have this part here in blue, 4, 2x minus 1. And now I'm going to use the exponent rules. Write that as one base, base 4, and then I'm going to add the exponents. Negative 2 plus 2x minus 1. So that's base 4, and collect like terms. 2x, negative 2, take away 1 is negative 3. So the g of x function that has base 4, the exponent is 2x minus 3. And then we're going to take the same f of x function, but this time we want base 2. So now I have to change 1 over 16 and this base of 4 because the question specifies base 2. So 1 over 16 becomes 1 over 2 to the 4, because 2 times 2 is 4, times 2 is 8, times 2 is 16. And then this base of 4, I'm going to change that to 2 squared. And then just remember to keep that exponent on your base 4, which I've now changed to 2 squared. So next I will deal with this 1 over 2 to the base 4, and I will combine these exponents by using the power of a power rule, which means multiply them. So I'm going to do both of those on one line, so that becomes 2 to the negative 4, and the second one, I now have base 2, and when you multiply those, you get 2 bracket 2x minus 1. Okay, remember, it's not just 4x minus 1, it's going to be 4x minus 2 because you have to apply 2 to both of those terms. Okay, so next I now have base 2, and I have a power on both of them, an exponent on both of them. So when I multiply those bases, I add those exponents. So I'll just do that in blue now. So 2, negative 4 plus 4x minus 2 to 4x minus 6. And then I will just write that over here. And then you can compare your answers for base 2 and base 4. And that makes sense because 4 is 2 squared, 2, and then that squared would multiply by the 2x minus 3. And that's why these are doubled. So our answers look good.